In this video, we'll see example on step shaft. The arrangement of the step shaft is shown in the figure. Shaft AB is of 80 mm diameter. Shaft BC is of 60 mm diameter. Shaft CD is of 40 mm diameter. And the length of each shaft is 0.5 meter or 500 mm. So length of AB is 500 mm. Length of BC is also 0.5 meter, that is 0.5 into 1000, that is 500 mm, and here also it is 500 mm. The important part is that we have to draw the torque diagram, and we have to find out what will be the torque in the individual section, that is what will be the torque in AB, BC and CD, and for that we have to draw the torque diagram. Now we have to find out the value of total angle of twist in this particular shaft in series, and value of G is given as 80 GPa. So let us first see how to draw the torque diagram. The conventions as usual, we are assuming that anti-clockwise torque they are considered as positive, whereas clockwise torque they are considered as negative. Here there will not be any problem because all the torques they are given, they are in the anti-clockwise direction, and hence they are positive. At point D there is an anti-clockwise torque of 880 Newton meter. So you can see this is the line of 880 Newton meter will remain the same just at the right of C. So 880 Newton meter, but exactly at C there will be a suddenly a torque of 220 Newton meter will get added to this 880. So there is a sudden rise in the torque exactly at point C, will remain same just at the right of B. So 3080 Newton meter, but exactly at point B there is a again sudden rise in the torque. So 3080 plus this 3300, so it is 6380 Newton meter, and then it will remain same up to point A because no other torque is acting between B and A now. So whatever the torque that is there at point A is nothing but the reactive torque also, because A is fixed. So there is a reaction or reactive torque that is offered by the fixed portion, and that reaction will be in the opposite direction to that of this active torque. So it is shown in the clockwise direction, and its value is also 6380 Newton meter. So the reactive torque that is developed at the fixed end is of magnitude 6380. Now you can see, you can identify the various torques over here. For portion AB, which is of 80 mm diameter, 500 mm length, the torque that is acting is 6380 Newton meter as indicated by this horizontal line. Shaft BC, which is of 60 mm diameter, 500 mm length, is subjected to the torque of 3080 Newton meter. You can convert this in Newton mm by multiplying by 10 raised to 3. Shaft CD, which is of 40 mm diameter and 500 mm length, is subjected to the torque of 880 Newton meter as indicated by this horizontal line. So all these horizontal lines, they will indicate the torque in various portions, that is AB, BC and CD. Whereas this particular torque is a reactive torque and its magnitude is 6380 Newton meter. So this is the meaning or interpretation of this particular torque diagram. So using these values, we can easily find out the angle of twist. So first just jot down all the values that just now we have calculated. That is torque in AB, torque BC, torque CD. All these values were in Newton meter. We have converted those values in Newton mm by multiplying by 10 raised to 3. Now we know that polar moment of inertia is pi by 32 d raised to 4. For portion AB, the diameter is 80. So just substitute the value of 80 in place of d, and you will get the value of polar moment of inertia as 4.0212 into 10 raised to 6 mm raised to 4. Similarly, for BC also the diameter is 60. So in place of d, substitute 60. So that value comes out to be 1.2723 into 10 raised to 6 mm raised to 4. And then for CD, the value of diameter is 40. So it is pi by 32 d raised to 4. So that value comes out to be 251.33 into 10 raised to 3 mm raised to 4. Now as the shaft is in series, we can say that total angle of twist will be equal to angle of twist in AB plus BC plus C. Now we know the formulation of theta. Theta is given by what? TL upon GJ for AB plus TL upon GJ for BC plus TL upon GJ for CD. So this is our torsion equation, and from torsion equation we have formulated the value of theta over here. Just substitute the value of torque. So torque AB is 6380 into 10 raised to 3. Length AB is 500. G is 80 GPa. So 80 into 10 raised to 3 MPa. So convert that value from GPa to MPa. And J just now we have calculated as 4.021 into 10 raised to 0212 into 10 raised to 6. Similarly, torque BC will be equal to 3080 into 10 raised to 3 Newton mm. Length of BC is 300 mm. G is 80 into 10 raised to 3, and J is 1.2723 into 10 raised to 6. Torque TCD is 880 into 10 raised to 3. Length of CD, portion CD, is 500 mm. G is 80 into 10 raised to 3, and J just now we have calculated as 251.33 into 10 raised to 3 mm raised to 4. So doing this lengthy calculation, you will get the value of angle of twist in radian as 0.046936. Now multiply it by 180 by pi so that it will get converted from radian to degree. So that value comes out to be 2.41 or 2 degree 41 minutes. So in this way, we can solve the example on step shaft. Thank you very much for watching.